over 17,000 miles an hour, the International Space Station has widened the world's knowledge in astronomy while exploring space in a whole new manner. Ideas were exchanged between scientists coming together from around the world, while they also encounter many problems along the way. Medical and technological platforms have been both explored and improved on Earth due to the findings on the International Space Station. The International Space Station has led to many astronomical discoveries, such as information on natural disasters, weather forecasts, cures for diseases, and further development in the knowledge of dark matter. The station has also brought together many countries in the exchanging of ideas and information. 15 countries have come together to work on the International Space Station and discover new statistics and ideas.
I like to use the example of the United States and Russia. During the Cold War, we were really enemies, and yet we have NASA and the Russian Space Agency working closely together. We've had astronauts and cosmonauts in space, members of the military who have trained to go to war against one another, but they're now working peacefully together on board the International Space Station. So I think the space station will be an example of how countries can work well together to accomplish amazing things.
The station was set as a challenge to NASA on January 25, 1984 by Ronald Reagan, who was president at the time.
Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
Before the International Space Station, the Skylab space station was set into orbit on May 25, 1973. The purpose of the Skylab space station was to develop science-based human space missions using hardware originally developed for the effort to land astronauts on the moon. The crew consisted of Commander Charles Conrad Jr., pilot Paul Weitz, and scientist Joseph Kerwin. The Skylab expeditions brought back new information that greatly enlarged the world's knowledge on long-term space habitation. The information gained from these missions led to a new era of space exploration. Scientists encountered a problem when designing the station. Since the station weighs approximately 925,000 pounds, it could not all be sent up at once. Their solution was to send up into space, piece by piece, the whole station, and it would be assembled in the zero gravity of space. Over 100 components have been sent up to the station, with a countless amount of supply missions along the way. The station is estimated to be worth $100 billion. The first piece of the International Space Station was launched on November 20th, 1998 by Russia. This was called Zarya. It provided battery power and fuel storage at the time, but is now used as a storage container. The piece was funded by the US and built by Russia. Because of this, it is a US part of the station. Weeks after Zarya reached orbit, Space Shuttle Endeavour connected the Unity module to the station. Unity, set up on December 4, 1998, was the first US-built module of the station. On November 2, 2000, the first crew began to construct the station. A month later, the station's first set of solar arrays, the P6 truss, were attached to the station by the crew of the Endeavour STS-97 mission. Now having the extra power from the solar arrays, the station's abilities were largened. Many more parts of the station were added. On February 7, 2001, the United States laboratory, the Destiny module, was launched. The lab was designed to be able to explore many different experiments, and it also has a window used to study Earth's features. On February 7, 2008, the Columbus module was sent to the station. It is European Space Administration's largest contribution to the station. The module was also the first permanent European research facility in space. The cupola, which was sent up on February 8, 2010, can be a work area for the crew, and it is also used when the crew controls the station's robotic arm. The module is where the Eastern Space Administration's Nightpod camera aid is located to help with precise pictures at night. Other parts, such as the robotic arm, mobile base system, and solar panels, were added. On November 2, 2000, the first crew began to live at the International Space Station. The crew of Expedition 1 consisted of Space Commander William Shepard from the US, Yuri Gintzenko, and Sergei Krikalev, who were from Russia. Staying at the station for 5 months, the crew installed different computers into the station and began to test different mechanisms in space. The second crew, Expedition 2, launched March 8, 2001, and they continued to do similar projects such as downloading new programs and conducting more experiments. Every expedition launched continues to explore scientific ideas that can be tested in space. 45 expeditions have been launched, with the members on board being of diverse ethnic backgrounds. Once living in space, astronauts encounter many problems. For sleeping arrangements, each astronaut has their own small room that fits a tethered sleeping bag to make sure they are not floating around. Also, with limited resources in space, astronauts have to conserve supplies. Scientists created a water filtration system that was installed into the station that allows astronauts to reuse water. Another problem encountered is the loss of plasma in the blood and the hollowing of bones when humans are in space for any amount of time. Due to this problem, scientists had to invent a zero-gravity treadmill, lifting station, and bike that worked in space. Astronauts on the International Space Station are required to exercise 3 to 4 hours a day. Many scientific findings have come from the evolution of the International Space Station. One experiment discovered how to transfer medicine through the body in a more productive way. The medicine created directly targets cancer cells, and the microgravity research on the station was necessary to explore the process. Better materials for future space travel has also been achieved. The materials will help reduce the health effects on humans when they are in space for any amount of time. The International Space Station has also created water purification systems for at-risk areas, and these machines were created from the technology designed for the water filtration systems on board the station. The new machine, called the Image-Guided Autonomous Robot, or IGAR, is modeled after the design of the International Space Station's robotic arm, and the new machine is a surgical robot. Medical and technological platforms have been improved on Earth due to the findings of the International Space Station. Private companies such as SpaceX and Boeing now send supplies to the International Space Station due to NASA's shuttle program being shut down. These companies have been encouraged to create reusable space rockets that have widened the possibilities in space and have saved resources. More modules are still being added to the station. On April 8, 2016, the Bigelow Expandable Activity Module was sent up to the station. The new expandable module is being tested to be used in future habitable structures for astronauts on long-term space missions, such as future Mars explorations. Starting as only a basic idea, the International Space Station has evolved into a magnificent structure dedicated to exploring science and exchanging new ideas around the world. Many scientific developments have resulted from the project, and more advancements will continue to come.
America has always been greatest when we dared to be great. We can reach for greatness again. We can follow our dreams to distant stars, living and working in space for peaceful economic and scientific gain. NASA will invite other countries to participate so we can strengthen peace, build prosperity, and expand freedom for all who share our goals. Just as the oceans opened up a new world for clipper ships and Yankee traders, space holds enormous potential for commerce today. The market for space transportation could surpass our capacity to develop it.